Good day, this is Professor Will, CBMD PhD, and today is Thursday, July 15th, 2021. It is 2:54 and 31 seconds a.m. Eastern Standard Time. Today's research, the Paleolithic era. So let's hop to it here. Light and Darkness, an experimental look at Paleolithic cave lighting. Date June 16th, 2021. Source PLOS. A recreation of three common types of Paleolithic lighting systems: torches, grease lamps, and fireplaces. Illuminates how Paleolithic cave dwellers might have traveled, lived, and created in the depths of their caves, according to a new study. Humans need light to access the deepest areas of caves, and these visits also depend on the type of light available, as light intensity and duration, area of illumination, and color temperature all determine how the cave environment can be used. Researchers use archaeological evidence of lighting remains found across several Paleolithic caves, featuring cave art in southwest Europe, to experimentally replicate the artificial lighting systems presumably used by the original human cave dwellers, allowing immediate empirical observations. The authors conducted their experiments at Incencia 1 cave in the Basque region of Spain. The replicated lighting was based as much as possible on archaeological evidence found in similar Paleolithic caves, and included 5 replicated torches made variably from ivy, juniper, oak, birch, and pine resins, and 2 stone lamps using animal fat, bone marrow from cow and deer, and a small fireplace, oak and juniper wood. They found that the different lighting systems all had diverse features, suggesting their likely selection and use across different contexts. Wooden torches made of multiple sticks work best for exploring caves or crossing wide spaces, and since they projected light in all directions, up to almost 6 meters, in the experiments, were easy to transport and didn't dazzle the torch barrier, despite having a light intensity almost 5 times greater than a double-wick grease lamp. The torch light lasted for an average of 41 minutes in this study, with the shortest-lived torch burning 21 minutes and the longest burning 61 minutes. The torches tended to function irregularly and required close supervision when burning, though they were easy to relight via oxygenation, moving the torch quickly side to side. The authors found the main torch disadvantage was the amount of smoke production. In contrast, grease lamps work best for lighting small spaces over a long period. With a light intensity similar to a candle, they were able to light up to 3 meters, or more if larger, where multiple wicks were added. Though grease lamps weren't well suited for transit due to their dazzling effect and poor floor illumination, they burned consistently and without much smoke for well over an hour, complementing the use of torches. The authors made one fireplace, a static system, which burned very smokily and was extinguished after 30 minutes. They note that the location was likely not appropriate due to air currents in the cave. The authors note that the practical insights and observations gained from their experimental replications are invaluable for a deeper understanding of what it may have been like to access the darkest parts of inhabited caves, especially in order to create art, and emphasize that future experimental lighting studies will be useful in continuing to unravel our ancestors' activities in their caves. The authors added, the artificial lighting was a crucial physical resource for expanding complex social and economic behavior in Paleolithic groups, especially for the development of the first speleological explorations, and for the origin of art in caves. Good day, this is Professor Will, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.